Hello, everyone. In this class, we will learn the concept of synchronous generator parallel operation to ensure the power supply quality of the generator and to improve the stability and reliability of generator operation. Power plants often operate multiple generators in parallel. Many power plants are paralleled to form regional power grids, and thus regions can be interconnected to form a modern power system as needed. Forming a modern power system, also known as the infinity power grid. Since the infinity power grid consists of multiple generators, its capacity is very large. There are different operation conditions. Its operation conditions will not be significantly affected by changes in the operation of any single generator. Therefore, it's usually defined that the voltage and frequency of the infinity power grid remain unchanged. This chapter focuses on the issues related to the operation of generators connected to the infinity power grid during operation. Parallel operation of generators is beneficial for power plants to adjust the number of units in operation according to load changes. It can also improve the operating efficiency of units and facilitate maintenance and help improve power supply reliability, as well as reducing the reserve capacity of units. The process of connecting a generator to the grid is called paralleling of synchronization. To avoid generating large inrush currents during synchronization and to prevent damage to the synchronous generator and disturbance to the grid, the generator must meet the synchronization conditions. Depending on the excitation condition of the generator to be paralleled, the methods and conditions of synchronization vary. Currently, there are two methods of synchronization. One is a quasi-synchronous method. The other is the self-synchronous method. Quasi-synchronous method. The conditions for quasi-synchronous synchronization are to adjust the generator to fully meet the synchronization conditions before closing the circuit breaker, known as the quasi-synchronous method, is mainly used for synchronization during normal system operation. The synchronization conditions include 1. The generator voltage and grid voltage are equal. 2. The generator voltage phase and the grid voltage phase are the same. 3. The generator frequency and the grid frequency are equal. 4. the generator phrase sequence and the grid phrase sequence must be the same. Among those conditions, phrase sequence consistency is an absolute condition, while other conditions are relative. Therefore, the generator can usually withstand some small inrush currents. The phase sequence of the generator is determined by the rotor direction. The generator manufacturer has clearly specified the direction and marked the phase sequence on the generator's output terminals. As long as it's properly commissioned according to regulations, after installation or overhaul, this condition can be automatically met. When a synchronous generator is paralleled with the grid, with the same phase sequence, its equivalent circuit diagram is as shown in the figure, meeting the remaining synchronization conditions, means making the generator terminal voltage equal to the system voltage. Delta U equals E0 minus E equals to UF minus U is 0. So the loop voltage is 0. Thus, when the switch K is closed, there is no inrush current for either the generator or the system. There is no inrush current. The process of quasi-synchronous synchronization involves checking the synchronization conditions and determining the closing moment. In power system of power plants, the varying method shown in the figure is usually used. The system voltage and the frequency are monitored by the voltmeter V1 and the frequency meter HZ1. The voltage and the frequency of the generator to be synchronized. The voltage and frequency of the generator are monitored by the voltmeter V2 and the frequency meter HZ2. S is the synchroscope. Its appearance is as shown in the figure. It can monitor the frequency difference and the voltage phase difference between the generator to be synchronized and the system. The synchronization operation steps are as follows. 1. Start the generator and increase the speed to near rated speed. 2. Apply excitation. Adjust the excitation current of the generator so that UF is approximately equal to U. Make the readings of V2 and V1 the same, and adjust the speed so that the readings of HZ2 and HZ1 are close. 3. Use the transfer switch to connect the synchroscope S. 4. Fine-tune the generator speed so that the synchroscope pointer rotates slowly in the clockwise direction. 5. Observe the rotation of the synchronous pointer. When the pointer approaches the synchronization point, quickly close the breaker to complete the synchronization operation. After successfully closing the breaker, disconnect the synchronous S. Adjust the generator to fully meet the 4 synchronization conditions above, and then connect it to the grid. The method is called the quasi-synchronous method. Its advantage is that there is no inrush current between the generator and the grid at the moment of connection. The disadvantage is that the operation is complex and requires a long time to adjust. It's especially difficult to synchronize when the grid is in an abnormal state with constantly changing voltage and frequency. It's especially difficult to synchronize using the quasi-synchronous method. Therefore, it's mainly used for synchronization during normal system operation. In the event of system faults, quickly connecting the unit to the grid, the self-synchronous method can be used. The self-synchronous method refers to a synchronous generator without excitation. Connect with the excitation winding short-circuited through a resistor, then starting the generator. When the speed is close to the synchronous speed, close the parallel switch to connect the generator to the grid. Then immediately apply direct current excitation relying on the electromagnetic torque formed between the stator and rotor can quickly bring the rotor into synchronization. The self-synchronous method is simple and fast. The disadvantage is that there is an inrush current when closing the switch and applying excitation. It's generally used for emergency synchronization. Thinking question 1. Please explain the conditions and methods for synchronous generator parallel operation. Answer. Quasi-synchronous method. The synchronization conditions include 1. The generator voltage and the grid voltage are equal. 2. The generator voltage phase and the grid voltage phase are the same. 3. The generator frequency and the grid frequency are equal. 4. The generator phase sequence and the grid phase sequence must be the same. Currently, there are 2 methods of synchronization. One is the quasi-synchronous method. The other is the self-synchronous method. In this lesson, we learned the basic concepts of the external characteristics and regulation characteristics of synchronous generators, the conditions and methods for synchronous generator parallel operation. We hope everyone will do more exercises. after class to consolidate the knowledge from this lesson. This lesson ends here. Thank you, everyone.